So welcome back to me playing with my little PicoDisplay, Python and rudimentary game programming. Everything I do is still based on that original ball demo. A lot of the things I'm showing you aren't the most efficient way of doing it, definitely not. The Pico's only got limited memory. For what we're doing, the way we're using memory is fine. If you want to find a way to totally optimize your game code to write proper games, one really excellent video is one that was done by Ben Heck, where he wrote a complete game of Space Invaders on a Atmel Teeny, and all of the code that he wrote had to run in between the scan lines of the television that he was outputting to. An amazing piece of coding, and that shows you how to optimize code. This is not that channel. I do appreciate and find really interesting learning a load from some of the comments that I do get. Today I want to come back to this little blitter program that I wrote. We applied this to the UFO and it worked fine. Because this is such a simple little sprite, I just want to go back to this program. So let's just run that again and check. This is drawing my little aeroplane. I've got a red and a white and a black in that. So I'm going to get rid of the colours that I don't need at the moment. Red, black and green. Then I'm going to move the plane back to its 0, 0 position. In the first video where I was playing with framebuffer, I started to explore what was in the first 2 bytes of the framebuffer. You see at the moment I'm outputting and it's saying 0, 0, but that's really because of where I'm writing that to the screen. At the moment the screen's black and it's cleared, which is why there's 0, 0 in that first byte. So if I move that to after where I blit the plane to the top, if I run it there, then that number should change. Yeah, so 152, 0. And that represents what I'm putting it in for red, the tail fin. So 155, 0, 0. And I mentioned in one of the descriptions of my previous video why that's not 155. So go back and have a look at that if you're concerned. It's 152 because we're not using all the bits to store that number. So just to prove what I'm doing is really altering it, let's change that red to green and run that again. So I've now, you can't really see it on the screen, but I've got a green tail fin. And the numbers change. The numbers change drastically now. It's changed to 4192. We've established that what is in this buffer is a set of numerical values. But let's have a look at the plane buffer now. So the plane sprite, that's all we're using at the top of that screen. But that plane sprite is there and that's got that plane buffer. And change that to plane buffer. Oh, it's called plain buffer, isn't it? That's smaller than the big display buffer. So I just wanted to show you what happened when we printed that to the screen. So let's have a look. So we get a fantastic byte array there that comes out. So that's interesting as it stands. So we've got this this 04, C0, 04, C0, and that's that definition of that green. If we look at it then we get a lot of blacks, 0, 0, 0, 0, 0, and then we get a lot of FFs towards the end because the bottom of it we've got white. So that's the whole byte array. I wonder what would happen then if we take this byte array from here. Let's just copy that, and instead of drawing this sprite here, maybe if we go to the top and where we define the byte array here for the plane, I wonder what would happen if we use this instead. So I'll paste it in. It's a big horrible number, big horrible value, but that's a byte array. And maybe we just say, let's make that plane buffer equal to that byte array. And I'll need to comment that out. So if we've got that byte array here, what's that doing? It's instantly building up that plane graphic in memory. If we run it now and it doesn't crash, exactly the same things happened. But this time, instead of starting with this byte array that's empty of 20 times 10 times 2 bytes, we're actually loading the bytes directly into it. And that byte array, again, it's not that efficient, but it's doing what we want. So if we now, on the draw plane, In fact, we don't even need the draw plane. If we go down to where we run the draw plane, and let's comment that out. Hopefully if I run that, now where is that plane coming from? We're not running that draw plane anymore. Just to verify that again, let's just completely comment out everything that draws those 3 rectangles to make our plane, and now run it again. And the plane is still there, but we're no longer drawing the plane because we've got this plane loaded up into memory here. Now again, this is not the best way of doing it, but it's just to show a different approach to building up our graphic to start with. So you could have a set of different byte arrays for each of your graphics, and if there was enough memory in the Pico to do it, you could set them all up like this. Of course, with ours, with what we've done so far, there's been a very simple plane image. We've only had one plane. With the UFO, there's only really been one UFO definition. And with our Flappy Bird, there's only been one Flappy Bird. We've not used any other graphics. So for the very simple games that we've been writing on this, this has been okay. Let's apply what we did to the UFO sprite. So let's just open this up. UFO blit. So save that. At the point that we create the alien, which is make UFO, isn't it? Here, let's just print it out. We're only going to make this one. So from the previous one, I had print plane.buff. And what did we call it? We've got a UFO grid, UFO array. It's UFO array, UFO array, and hopefully that gives me the byte array, and my UFOs are spinning as they were. And then here, let's grab this byte array. See, this is getting bigger and bigger and bigger, so it's using more memory anyway, but at the moment we're not worried about this. We'll come back to this and make this a bit more efficient in another video as well. But to build that array, instead of all this code here now, all I need to do is back up here where I say that this is the byte array. I need to paste that there. So UFO array equals byte array. Again, that should run and not crash unless I've typoed anything. Okay, it's still working. We don't need that print now. In fact, to prove that we've got rid of this, we've printed it there. So you might, if you were coding something like this, you'd have to do something that creates the graphic first. And once you've created the graphic and you've grabbed it out of this structure, then you'd get rid of the creation routine, because then you could use that code instead. Make UFO, we don't want to make a UFO anymore because that frame buffer should already have the UFO in it. So let's clear this. If that doesn't run again, we're not running make UFO, and let's run it. And the UFOs are ready built in there. As I said, not a perfect way of doing it, but we can see how, because this is already some form of structure, we're able to grab what's in that byte array and create a byte array instantly without having to use this bit. But this bit might be useful when you were building your graphic, if you were building it just in Python like we've been doing. I mean, I used Python and a spreadsheet to design this graphic, didn't I? When we actually looked at this array here, let's just pop him back in for a minute to bring that array back on the screen. If we look at this, there's an awful lot of black in this graphic. Most of these values are zeros, and then suddenly we use the 0, 4 because we're only using green in this UFO. So suddenly all of these are 0, 4, and that's all there is. And we're using 2 bytes for each pixel, when all we need to know really is whether this pixel is green or black. Likewise with the Flappy Bird, we were storing an awful lot of information, whereas all we wanted to know whether the pixel was one of 3 or 4 colours. So maybe you can work out what we'll do in a later video using some of the code that we already used in Flappy Bird to try and store this definition in a simpler way and in a smaller way.